Looking at choosing a significance level, let's first revisit innocent until proven guilty. This came up when we were talking about hypotheses, the null and alternative hypothesis, and we said if we're talking about innocent until proven guilty, innocence is assumed and therefore it is the null hypothesis, and guilt is what has to be proven, and therefore guilty is the alternative hypothesis. So a conviction that is finding guilty is coming out in support of the alternative hypothesis. And if we're coming out in support of the alternative hypothesis, that means that we reject the null hypothesis. So a false conviction, so any conviction is rejecting the null hypothesis. A false conviction is an error in which we reject the null hypothesis even though the null hypothesis was true. A false conviction means that the person was innocent but was found guilty. So this is going to be a type 1 error because we reject the null hypothesis to get it. All right. Now, a finding of not guilty, on the other hand, right? A conviction is rejecting the null hypothesis. So a finding of not guilty, that's the opposite. So that is failure to reject the null hypothesis. Now, a guilty person who is exonerated, who's found not guilty, that's our error, right? If the person is guilty but exonerated, that is an error. Since it's an error that comes from failing to reject the null hypothesis, it has to be an error of type 2. Just looking back at the table that's at the very beginning of the notes for this section. It's the only type of error you can possibly get from failure to reject the null hypothesis. Now let's think about this in terms of alpha as the probability of a type 1 error. If we were to use alpha equals 0.01 as our significance level, then the significance level means there is, following our model, a 1% chance of a type 1 error, which we just said is false conviction. So if we were to do this in 400 independent trials of innocent people, we would expect to see 1% of those 400 come out as false convictions. So if our trials really are using approximately a 1% level for that definition of guilty beyond a reasonable doubt, right? Proven beyond a reasonable doubt. If our reasonable doubt is there's a 1% chance that that person is innocent, but we're going to go ahead and convict, then we can expect that out of 400 independent trials, we're convicting 4 people. That's exactly what it means. Now, we don't quantify what a reasonable doubt means for partly this reason. It's really not acceptable to have any false convictions. But of course, we know that they do happen. So we do actually have some definition of reasonable doubt that could be turned into a number by statisticians if they knew exactly who was innocent and who was guilty of everybody who's convicted. Okay, so going on to choosing a level of alpha, there's 2 different things that we might try to prioritize. One thing is maybe our highest priority is to ensure a low probability of false conviction. Maybe our highest priority is to prevent guilty people from being exonerated and turned out onto the streets. In each case, we have a different objective and therefore a different choice of alpha. False conviction, we already determined above. False conviction is a type 1 error. And therefore, if our highest priority is to reduce the probability of false conviction, then we have to try to make it harder to have a type 1 error. Well, it's harder to have a type 1 error if it's harder to reject the null hypothesis, which means that we want a small value of alpha, but I was starting to answer the next question. So we're trying to avoid a type 1 error, and the way that we avoid a type 1 error is with a small value of alpha. It is harder to reject the null hypothesis if your significance level is small, because your p-value has to come out smaller than your significance level to reject the null hypothesis. Okay, and now looking at the reverse, if our highest priority is the opposite of this, preventing a guilty person from being exonerated, well, that's exactly what we already said was a type 2 error. Then what we are trying to prevent is type 2. The way we prevent type 2 errors is we make it easier to reject the null hypothesis, and in this case we would want a large value of alpha. I think most people would argue that the highest priority is what we said in number 17, that we really do want to make sure we're not convicting innocent people even more than we want to make sure that we are finding the guilty people and convicting them.